Hello everybody, welcome to Pencil College. In this video, we will touch on a new topic called kinematics, which is actually chapter 21 of your PenPack textbook. Okay, so this video I will give you an introduction on what kinematics is and how is it actually related to one of the sciences, physics. Now I want to introduce you to a very famous experiment. Okay, so this is the Leaning Tower of Pisa. And one day, Galileo stood up here and he dropped the ball. And he measured the time t taken for the ball to hit to the ground. And he took another ball, a heavier ball, and he dropped the ball and he measured the other time t. And surprisingly, the results were such that the two timings were almost equal. So this is to say that either the velocity is the same or the acceleration has to be the same. Okay, because the displacement is definitely the same. This is the same distance, okay, that is dropped. However, we know that velocity cannot be the same because if you were to jump down a flight of stairs, you would know that you will increase speed. Okay, so this increased speed is actually an acceleration. Okay, so physicists found out that if you have a displacement relationship with time, now when you differentiate this relationship with respect to time, what you would get is actually the velocity. And if you went to differentiate the velocity once again, you would get the acceleration. Okay, so this is to say that in reverse, if we were to do integration, and if I were to integrate a with respect to time, what I would get is actually v. Now, of course, plus a constant. And if I were to integrate v, I would definitely be getting s plus another constant. Alright? So with this, we actually, in physics, we actually managed to formulate a law, okay, which is the displacement is equals to s naught plus ut plus half a t squared. Now people will ask, how do I actually get, I should not use ut here, rather I should use vt, because I defined velocity to be v over here. Okay, so people will ask, how did we find this kind of relationship? Now we find it through calculus, which is integration, which is what we have been learning thus far. Alright? Okay, so if you can see that if you differentiate s one time, differentiate s ds dt, what I would get is equals to v plus half at will become just a times t. Now a times t is a unit, acceleration times time just gives you some speed unit. Okay, I call it weird v. Okay, and this is another speed unit. Okay, whereas if I went to differentiate this again, I would get d2s dt square, right? If I differentiated ds dt once again, I would get d2s dt square, and this thing would give me, because v will now not be related, so therefore it will just, there will be no t here for me to differentiate. V can just be a constant, and therefore this will give me a. Okay, which is what I set out to say. Alright, these two formulas we have here. So in fact, you can see that learning integration and differentiation helped us to derive physical laws, okay, which govern motion, given that let's say A is a constant, okay, which is what we said to say over here with the experiment at the Leaning Tower of Pisa. Okay, so I hope that gives you a good introduction on what we can find out in kinematics using just differentiation and integration. So basically, these two are the formulas that you need to know. Okay, so these formulas that are boxed are important formulas that we have to learn in kinematics. Okay, I hope I have given you a good introduction to what kinematics is, and I hope you are looking forward to learn about kinematics, because this is a topic that we actually apply the mathematics into science, and you really see this application of mathematics, okay, or applied mathematics in another words. So I hope you have enjoyed this video. For more videos, please visit www.pencilcollege.com.